We'll be dissecting the ear, which is an unusual dissection because you get a decalcified portion of the skull to work with in this case, so that you can easily cut right through bone even with a scalpel. Now we're going to start externally dissecting portions of the external ear to approach the tympanic membrane. And here you can see the external ear, the auricle or the pinna of the ear. And the first step in the dissection really is to dissect down through the external auditory meatus. And we've already made these scalpel cuts through the anterior wall of the external auditory meatus, so we can simply pull this segment of tissue away. We've removed that anterior wall of the external auditory meatus, and now, as you look down into the depths of it, you can see the tympanic membrane right down in here. Very thin layer, which has actually got ectoderm, mesoderm, and endoderm layers forming it. And you probably can't quite see it, but the malleus, one of the middle ear bones, does attach directly to the tympanic membrane. So again, we see that at the depth of the external auditory meatus. Now we're looking at the ear specimen from the internal surface. So we've got the cranial cavity inside here. This is the petrous portion of the temporal bone, which surrounds the structures of the middle and inner ears. Here you can still see the auricle, or the external ear. Now, some of the things that you'll be looking for before you begin the dissection would be the internal auditory meatus here, where cranial nerves 7 and 8 both enter the temporal bone and pass toward their targets of the ear and beyond. So what you want to do as you proceed with the dissection is to use a scalpel, again with the decalcified bone, and remove the roof over the internal auditory meatus, following cranial nerves 8 and cranial nerve 7 toward their respective targets. And we'll do that next. As we described, now we have removed the roof of the internal auditory meatus. We can see cranial nerve 7 here. And if I just reflect that for a moment, you can see the components of cranial nerve 8 as well. Now, because it's simpler, let's just start with cranial nerve 8. We don't have to follow it very far. As you can see, there are two branches here that are proceeding through the internal auditory meatus, and they will simply go off in their respective directions to innervate the cochlea and the semicircular canals, or the vestibular apparatus. You can see glimpses of these tiny special sensory structures as you're carving down through the petrous portion of the temporal bone. The very tiny spiral of the cochlea is here, and if I put cranial nerve 7 back in place again, you may see some teeny little sections through the semicircular canals which are responsible for the sensation of equilibrium. Now, picking up cranial nerve 7, also going through the internal auditory meatus, you can follow it a certain distance, and then it forms this T. Where that T happens is the location of a ganglion for cranial nerve 7. One branch from this point will head anteromedially, that is the greater petrosal nerve, parasympathetic branch of cranial nerve 7, which will ultimately innervate the lacrimal gland. The bulk of cranial nerve 7 will branch and continue posteriorly through the facial canal, which we've opened here, and that will provide the innervation to the muscles of facial expression, as well as a variety of other functions. Now, we've also exposed the middle ear cavity during this dissection, so that we can see two of the three middle ear ossicles. This is the head of the malleus. We cannot see the entire malleus. The remainder of it is continuing inferiorly and is attached directly to the tympanic membrane. Right here is the joint between the malleus and the incus, the second of the three middle ear ossicles, both of those being derived from branchial arch 1. Now, it's much too deep and too small for us to show you the stapes, the third of the ossicles within the middle ear. Okay. Another structure that we can show you, however, is a small muscle that attaches to the malleus that helps to control the movement of these ossicles as they vibrate. Here, running parallel with the greater petrosal nerve, is a muscle called the tensor tympani. And its tendon will make a 90-degree bend and attach to the malleus to help reduce the vibration of the tympanic membrane when you hear very loud sounds. One other structure we'd like to try and show you is an important branch of cranial nerve 7 that we talk a lot about, and that is the chorda tympani. It receives that name because it travels through the middle ear cavity, essentially right across the tympanic membrane. Now to see this small branch of cranial nerve 7, what we need to do is pull out the incus, because that will give us better exposure into the middle ear. And we've got this strand, essentially, passing between the incus and the malleus as it cuts through the middle ear and then continues forward toward the petrotympanic fissure where it exits the skull.